Alright, in section 10.2, we're going to be looking at the second derivative test. So the first derivative test tells us where something's increasing or decreasing. What the second derivative test is going to do is tell us whether something is concave up or concave down. Okay, so first, if we are asked to determine if a function is concave up or concave down at an indicated point, the first thing we need to do is take the first derivative. So that's going to be 3x squared minus 12x. And then take the second derivative. So that's going to give us 6x minus 12. All right, so what we are going to do is that we are going to take this point and plug it into our function, into the second derivative. So f double prime of negative 5 is going to give us 6 times negative 5 minus 12, which is going to give us, let's see, negative 30 minus 12 is going to give us negative 42. Now, here's what that tells us. If the second derivative is negative, that means that our function is going to be concave down at that point. Now, if we take x equals 6 and plug that in, we're going to have f double prime of 6 will equal 6 times 6 minus 12. So that'll be 36 minus 12, so that's going to give us positive 24. Now, since this is a positive number, that means that our function will be concave up. Alright, now for the second one, it asks us to determine the intervals of concavity for the following function. So whenever it talks about concavity, meaning where is it concave up or concave down, that means that we're going to have to find the second derivative. So the first derivative, if we bring that 4 down in front, it'll cancel out with that 1/4, so we'll be left with x to the third. Plus, bringing that 3 in front, that'll be 3/2 x squared minus 6x. Now when we take the second derivative, that is going to be 3x squared plus 3x minus 6. Now, what I'm going to do is I'm going to factor this. So I can pull a 3 out, and I'll be left with x squared plus x minus 2, which I can factor into 3 times x plus 2 times x minus 1. Now, the reason I factored it out is because to find intervals of concavity, I have to figure out what this equals 0. So 0 equals 3 times x plus 2 times x minus 1, which means I'm going to have critical points when x equals negative 2 and when x equals 1. Now, to determine the intervals of concavity, I'm going to make a number line. I'm going to put my critical points on there. And then I'm going to pick some numbers in between. So I'm going to pick the number negative 3, let's do 0, and let's do 5. Now, if I take these numbers and I plug them into my second derivative, I just want to know if I get a positive or a negative. So if I take negative 3 and I plug it in for my x values in my second derivative, so plug them in for my x values here, what I'm going to get is I'm going to get 3 times negative 3 plus 2 times negative 3 minus 1. So that's going to give me 3 times negative 1 times negative 4. What that's going to give me is positive 12. So what that means is that my second derivative is going to be positive for all the numbers on that interval. Now if I take 0 and plug it in, I'll have 3 times 0 plus 2 times 0 minus 1. What that's going to give me is that's going to give me negative 6. So because that's negative, my second derivative is going to be negative on all those intervals, or for all those numbers on that interval. Now if I plug in 5, what this is going to give me is that's going to give me 3 times 7 times 4, which ends up being a positive number. So that means that my second derivative will be positive for all those values. So what that means is that my function will be concave up for all the values from negative infinity to negative 2, and from 1 to infinity, because that is where my second derivative is positive. Likewise, it will be concave down on the interval from negative 2 to 1. So, in closing, remember, if your second derivative is positive, it's going to be concave up, and if your second derivative is negative, that means it will be concave down.